Hello, hello, hello. Today the streaming is, having few issues which we have never figured out because we have never faced those issues, but today we are facing those issues. Hello. I think that it's now all right. Condition is okay. We can start streaming. Hello. But there are still some buffers, buffering and all going on because of the low speed. Why is that? But it sometimes get the high speed. So let's try doing everything that we can from our side. So yeah, we have array and slices in match. So we have seen match, we have seen destructuring, we have seen for tuples, matching and all. We have seen array and slices also. But we'll go forward by first of all revisiting this old concept. Not very old, just yesterday. And then we'll move forward to enums, pointers, pointers or reference, and structures, and then guards, and then bindings. After that, if let else, and while let. That's it. So that will be our eighth module completed. So this is array or slices. But I don't know, this network is sometimes doing something funny with my stream because it sort of ended it earlier and I had to delete it and restart everything. So it took me about half an hour to now set up everything. So let's get started from array and slices. So we have read this array and slices. In this, we first of all create a main function. Inside this, we have let array is 1, minus 2, and 6. And we start to match this array with all these conditions. 0, second, and third. 0, we don't care. And third, it was not 0, it is 1. A minus 1, second, and whatever. All right. Ignore the rest. Don't care about these. And the same goes on here also, like minus 3 second and tail at the rate. We don't care. But why at the rate? So we'll see that first, middle at the rate, dot dot, and last. So yeah, we've seen it. We've seen it all. Now let's get to it of what it's doing. So if the first element is zero, which is zeroth index is zero, first index is whatever, second and this second element, second index. Let's call it element wise. So first element, second element, and third element. Otherwise, the naming and all that makes it very confusing. So if first element is zero, second element is second, and third element is whatever, minus 6, 6, whatever. Then we just print the array 0 as 0. Array at 0 index is 0, array at 1 index is second, and array at 2 index is third. That's what we do. Now, single values can be ignored with 1, and this is, wildcard, so whatever comes up of here, and third. So let's say if array 0 is, we wanted to print 1, and array at second position, we wanted to print, the second position of it. As for the first position, first index in array, we try to ignore it. So we see that array 1 was ignored. All right. Now you can also bind some and ignore the rest. So we bind the zeroth index and the first index. As for the third index, we don't care. So we are like, go on, ignored. All right. This dot dot. So we see the same response as array 0 is minus 1 because it's there. And then what is? Then array at index 1 is second, and all that other ones were ignored, which is like second comes up over here, and all the others, whichever it is, get ignored. So let's do that. Minus 1. minus 6, and let's say 5. It will not work because there are 4 elements, but we are only comparing 3. Let's see the error. It said expected was 4 element, but array has whatever expected 4 elements. Well, pattern required 3, but array has 4. So didn't expect, but that's what it's telling us to. Now line 11 is satisfying it. So line 11 over here. Yeah, now this satisfies. Oh, now what? I will just print it that zeroth index is -1, first index is -2, and all others were ignored. So all these 65 and all that were ignored. So let's comment out line 11th also. All right, we commented out, and now if we run it, we should get into this one. We didn't. Why? Ah, because of this. Now there shouldn't be much of an error. Yeah. Now we see that first index at 0th and first index is -1, -2. That's what we are seeing over here, and all other ones were ignored. So I want to see if we can take 4 elements over there also. Like if it's ignoring everything after that, can we take 4 elements, or it can only take 3 elements? Ah, it takes whatever elements is present. So it takes anything. So it is now taking 4 elements. Which one? I'm talking about this one. So it doesn't care if there is a third element, fourth element, fifth element, sixth element, whatever. We just want to print zeroth index and first index. So that's what we are doing over here. Over which also the zeroth index should be equal to -1. That's what is predefined. And over here also. So this is the case we are matching to, and we are getting this response. Therefore, we have 4 length of array. So it all works. Let's see this one also. Will it, you know, take the, will it take the fourth element also, or will it force us to get just 3? I think it will be 3 because, it didn't. But that also, where is it matching right now? Oh, it is matching over here. So it says something like first element is -1, which is good. And then middle at the rate, whatever. So we get first and last, and in middle, whatever the, whatever the element is, we are taking it as middle. So we had first and last is 5. Then this became the middle, and it took it all quite happily. So let's change the last element to something more ridiculous. 100. Well, not 100. Like this, and now this. Now last element is 35. First element is -1, and in between it's middle. So will it do it? Yeah, it did. It just did. So these are now middle elements. This is the last one. This is the first one. Good for it. So we'll sort of comment it out. But now we know why this at the rate and whatever this is and what it means. So first of all, it was ignoring everything after this double dot. But now it is first of all taking the middle element, and it's taking the before the last element, whatever it is. It's taking everything. Interesting. And we are calling it by just middle. because it is assigning middle the value of everything plus the middle value. So something like this. Now that's what we call interesting. I think we didn't notice it yesterday because we were not uncommenting. We were not commenting every line out, so we sort of didn't notice it. As for this to happen, we must have a three at the first. So let's get over there, and instead of making -1, we shall include a three in it. So let's go. Will it print? I think so. Ah, there is an error. What does it say? So line 5 match array, then line 26 near this. So what is it? 25, 26. Where is 25? 25 is this. 26 is this. So it says something that we have to do, and I don't know what it is. So I know what we'll be doing. Let's try. Which line has the error? Well, what I expected it to do was, first of all, it's defining that first element should be 3, so it is 3, and now we should be getting, array 0 as 3. As for array 1, we should be getting the second, which is we are getting second, and other elements were whatever. This tail is encompassing all of the rest of the elements. So that's what we were, you know, gonna get it, but now I don't think that's the case. Or is it? Because since there's only one match, I think we don't need a comma. Or we do. We don't care. So there is a line 5 in 23, 22, 23. And note the matched values of type I32 and 8. Alright. I32 and help ensure that all possible cases are being handled by adding a match arm with a wildcard arm. So multiple match arms. So it says 3 second and tail, which is trying to print the 4 I32 is equals to I32 max. You have to do something with this. This is I32 min is equals to 2 I32. Now we have never seen this error, so I don't know what it's telling us to do. But it is something like handle all the cases, and I think we should handle all the cases. Well, it should have been handled automatically, but somehow it is not. How about we just comment this out and we uncomment the last one, because this was the very close that we could get to this, at the rate and all that. So let's run this. I was running, it was running fine. So instead of, now middle, we say just get a last one, and then we'll get our middle, and ideally, right? So there is an error. Yeah, we know it. It is because of this. So we'll cut it from here, go to the last one, we'll paste it over there, then we try to run it. And it runs. It runs normally. Well, not very normally, but still. Last looks something like this. LAHD last looks something like this. And this is not array 2, this is array 1, array version 1. It timed out, but yeah, we did it. All right, we did it. We got this case to be handled. As for why this was not getting printed, because I think it is, pre-defining something like 3, and if there are other cases too, it wouldn't be able to handle it. So let's try that again. Yeah, now we are getting this. Why? Because if array 0 is not 3, what will we do? Match was then inexhaustive in that case, because we are not matching everything. But now we are matching the first, middle, and last. Earlier we were watching matching just 3 if it is 3 by any case. If it is not, then it was just roaming around this match and nothing could be found around. But now, since we are adding this, you know, adding this value to it, if purchase anything, come to us, come to me, something like that. That's why we got away with that error we were getting at 20, 22, 23 line. Combining these patterns, we can, for example, bind the first and last values and store the rest of them in a single array. All right, and this is the response for this one. All right, so array 0 is third, array 1 is -1, and the last elements were exactly what we expected. And this is running right now, this one, not this one. Because as soon as we go over here and say something like array first element is 4, then it starts running the last one. Yeah, this is our last one. But let's say if it is our 4, but we are not handling that case also. We are just leaving it alone and we are just handling the case for 3 as a first element. Then what happens is this match is sort of is not exhausted right now. So that's what it's telling us, that there is something non-exhaustive pattern. So for non-exhaustive pattern, you have to somehow exhaust all the uh, possibilities. So just use some sort of wildcard. That's what it's telling us somewhere. Ensure all possible cases are being handled, and by adding a match arm, wildcard pattern, a match arm with multiple, or a pattern as shown, or multiple match arms. So it's trying to help us. It was just we were not uh, ready to take this in, but now we are, and we took it. So it just means that we have to uncomment these and all other cases, and if it is one, and this is one of the other cases where we have first element as 4, not as 3. All right, let's move on to our today's topic, which is enums. Oh, I saw something like two others, but let's move on. This is enums. So now what? An enum is destructured similarly. So enum is also destructured similarly to, I guess, structure. We have seen structure or not? No, we have not seen structure, but it's telling us enum is also destructured similarly. Similarly to what? Tuples or arrays or slices to what? So let's see. Allow required to silence warning because only one variant is used. So if there is any dead code, well, allow and something like that will which will suppress the warning. All right. After that, we are going like enum color. We have a color for enum which is red, blue, and green, and these likewise tie to a U32 tuple to different names and color models. So we have RGB, which takes three U32s, and it is a tuple. Inside the color, we have HSVs, which again take two U32s, three U32s, and then we have HSL, same, CMY, same, as a CMYK, this is different. Now we have four different U32s. So these are now all the tuples. These are tuples. these tuples, these are tuples, these are tuples, these are tuples, all are tuples. Now we have, these tuples in a color or the enum color. So now it tells us that there is a main and let color is equals to, RGB and 122, 17 and 40. So inside color structure or inside the color enum, we go to this RGB and assign these U32, 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 some values like 122, 17 and 40, and we are assigning that to a variable called color. It's telling us try different variants for colors. We will later. Let's first of all get to this, that what it is doing. Wait a second. Yes, so our streaming is also working. Nice. So yeah, we were here where we have a color, small color, which has a type of color and taking RGB's values 127, 122, 70, and 40. And then we are trying to print what color it is. So an enum can be destructured using a match. So if it is directly color red, then we print the color is red. If it is directly color blue, we print it is color blue. If it is green, we print that. If it is RGB, tuple RGB with value R, G and B, we print all these values. If it is HSV, we print that. If it is HSL, we print that. If it is CMY, we print that. If it is CMYK, cyan, magenta, yellow and key, which is black, then we print all of that. But while printing, it is for us and we are giving it over here. Yeah. And don't need another arm because all variants have been examined. So this is now exhausted. It is not a non-exhaustive case. So let's try running it and we should get something like RGB. So what color is it? So we are getting red is 122, 17, green is 70 and blue is 40. How we were doing it? We were doing the match on the variable color, which was of type color red, color RGB, but we were matching all these enums inside color. So like every possible cases. So color red, color blue, color green, color RGB, SS, HSB, HSL, CMY, CMYK, and all that. So now we know what was happening over here, and this was well reasonably quite easier than array and slices somehow, and it all works as per changing these values. We can do that by this. This is just to do. Yeah, we get the R changed values. If it is not RGB, which we can say just HSL, HSL, and it will match with that only. We'll get color is HSL. Yeah, hue is 12, saturation is 17, lightness is 40. Now I think we can move on from enums, which is obviously destructured very similarly to tuples, sort of. And we are also using the elements inside those tuples. So exactly like tuples most of the times. Now we are at pointers and references. And this is also some short program. So for pointers, a distinction needs to be made between destructuring and dereferencing. So destructuring is different, dereferencing is different. And why distinction is needed for pointers? Because as they are different concepts which can be used differently from languages like C or C++. So dereferencing uses the star. Yeah, we know that. And destructuring uses the ampersand, reference, and reference mutable. We sort of know that also, or now we know that. we use ampersand, reference, and reference mutable. This is destructuring uses. Whereas dereferencing, which is like there is a reference to something, dereferencing. Don't take the reference for this. Don't take a mutable reference for it. Just dereference it. So now we have a main, and we assign a reference of type I32, and ampersand signifies that there is a reference being assigned. So let reference is equals to a reference of 4. So 4 can be copied very easily, but still, why are we doing this? I don't know right now. And then we are matching this reference variable. So if reference is a pattern matched against ampersand val or ampersand value, it results in a comparison like ampersand I32 and comparing with ampersand val. We see that if the matching ampersands are dropped, then I32 should be assigned to val. Okay. So we have a reference which is of type, ampersand 4. So reference of I32, and there's a ampersand val, which is again this thing, which is 4. And we are destructuring it by saying, we have a val and we are printing that value over here, which is 4. So we have to get through this again. So we are matching the reference. So if reference is pattern matched against ampersand val, which is value of itself only, so it results in a comparison like I32 and ampersand val. We should see that if the matching ampersands are dropped, then I32 should be assigned to val. All right. So try running it, and it should run something like got a value via destructuring, which is 4 and something like that. Now we have to avoid the ampersand, you dereference before matching. So to avoid this ampersand everywhere, like this ampersand val, and if there are other cases like ampersand val or lal or anything like that, you would have to use ampersand. So instead of using that ampersand, we just directly dereference it over here. So we dereference the reference and then pass the value, which is val, and we try to print a destructured value. They both will work, or sort of should work, but it timed out. So can we try it again? If it doesn't work, we'll go to our own environment. Yeah. So got a value via destructuring first, and then we got a value via dereferencing. Now they both are good, they both work. We have seen it somewhere. We know we have seen it, and it is working absolutely fine. Now, what if you don't start with a reference? So reference was ampersand, because the right side was already a reference. Now this is not a reference because the right side is not 1. So now we have a variable which is not a reference, and we have a value 3. Now Rust provides a ref for exactly this purposes, for this purpose. So now we just create or add a ref keyword to it, and it becomes a reference. So instead of doing it with this not a reference variable, we do it with a is a reference variable with the same structuring. Just the variable name is different. That doesn't make it referenceable. This keyword ref is making it, be referenced. So it modifies the assignment so that a reference is created for that element. Now this reference is assigned. All right. So instead of directly assigning 3, a reference of 3 is assigned. Accordingly, by defining two values without references, accordingly, by defining two values without references, the references can be retrieved via ref and ref mute. So if there is a value 5, so there is no reference to it. But over here we have a mutable value of 6, which is mute value. These are just normal assignment, no referencing and no dereferencing for them. But what we are trying to do is, instead of directly taking value inside a match, which might just copy that value, and we might be able to, just go with it. But instead of, copying, because copying can be memory intensive, we have seen that in NumPy. So in those cases, or some cases, copying can make program slow or worse because of memory bandwidth and bottleneck with memory. Arithmetic is very fast. That's what we learned yesterday in Python. Our day 7 was just about Python. We didn't even got a chance to start sort of Rust, but still we spent approx 5 to 6 hours on that. So now we match a value. We are taking the reference of R. What is R? Oh, inside the value, this is a value which is 5, and we are taking the reference of 5, and we are trying to print it like got a reference to a value which is value, and the R is 5. That's it. Now we match the mutable value which is 6, and we are saying ref mute, which is, now we are taking a mutable reference of m, and we are doing what? Got a reference, got a dereference it before we can add anything to it. So we then are dereferencing this, and then we are trying to mutate that, and then we are printing it. So it says we added 10 and mutable value is now 16. So we first of all dereferenced it. All right. So M was a reference, and then we dereference it so that we can do some operation on that mutable reference, which we did. We made it 10, and then we printed it. But now what I want to check is, did it really made the reference the mutable, or did it really change this whole mutable value? So what I can do, what we can do, is print this mutable value just after this match. So match ends over here, I guess. And we say that not quitting, uh, print ln, and it is a macro. Oh shit, what happened? Control 9. Uh, it is a macro. Inside that, we need what? We are saying, you know, print this, printing of satisfaction, and we are printing a mutable value. Can we do this? So yes, it took this mutable value and referenced it as a reference which was mutable, and then we muted changed the value. We just added 10 to it, so it did not just go to this reference and change this reference m, but reference was going over here also, so it changed the whole 6 to dan 16, and now we are getting a value or mutable value as 16, not 6. That's important. If we were to just print this thing uh, just few lines above, we would have, or we will still get 6 before dereferencing it and doing some operations, adding plus 10, and then changing the value. So over here we can see we have a value for our dissatisfaction. All right, we have 6, and after that we have 16. Nice. I think we can move on. We know what dereferences use. It just dereferences whatever reference we have, and destructuring and uses this ampersand reference and reference mutable. So what we were doing over here was destructuring with reference mutable. What we were trying to destructure? We were trying to destructure this value of 4 or 6, not 4. Sorry, my bad. I said. So this ref pattern, where is it taking us? Let's go. Let's go. Let's see. So the ref pattern, is it different in which module it is? It is in scoping rules. So we'll get there. We'll eventually get there. We are still in 8 modules. So yes, we shall move on from pointers and references to structs, which is our last sort of subtopic in destructuring inside this match. But we still have guards and minings. So all right. Now structs. So similar Similarly, a struct can be destructured as shown. So structure can be destructured. Now that makes some sense. So we have a main function. Inside that we have a structure foo, which has value x and y, whereas x is a tuple which takes u32, u32, and y is just u32. So try changing the value in the struct to see what happens. We'll do that. We'll do that in a minute. So foo is equals to this structure foo. Inside that we are assigning x a value and y a value. All right. Then we sort of try to match the foo with x. So x is 1 and whatever this b is, and then whatever this y is. Then print x is 1 and b is, and then y is this. That's what we are trying to do. If there is another match, something like y is if 2, if this is 2, then x is whatever this is, I, just print that tuple. We don't care. And if y is all we care about and we don't care about anything else, we can just do that and this will print y, but we don't care about x. So we are not printing it. And then we get too far, but we don't want to get too far right now. So let's just comment it out, not this name. Now what? I'll print this or try it. We should get this one, this case, because x is 1. See, x is 1, b is 2, y is 3. And if we, semicolon this, or let's say we change this x1 to something like 4 and y to something like 2, because now we want to see how the second case prints, and y is 2 and x is whatever, we don't care. We should get, I guess, this value or this value, but we'll get this because it matches first, which is 2. If it was written below, then obviously this would have matched in every possible cases before even going to this. So order of matching also matters. We know that. We obviously know that, because before matching just 2, if we matched all the cases for y, then obviously it wouldn't come to 2 after that. So now we should be getting this, which is y is 2 and I is whatever the I is. I is 4 and 2 is a tuple 4 and 2 and y is 2. Yeah. What if it doesn't match to 2? Let's say we make it 3 or 9. Then it will come to the third case where it will just print the y and we don't care about the rest, which is x tuple. We don't care about that. So yeah, y is 9 and we don't care about x. That's it. That's what I wanted to see. And we sort of saw that. Now we uncomment these slides so that we can see what the far is, right? So far, well, there's a meme going on with all these far as a noises, right? So yeah, it is funny for me right now. After a year or two, it will not. So far is again a structure of foo, which has x, which has a tuple of 1 and 2, y is 3, and what we are trying to do is you don't need to match block to destructure structure. So we are just saying foo, then x is x0, y is y0 is equals to far. So we are dereferencing this far to something like foo over here. All right, and then we are saying what? Print ln, then outside, which is xo, then we are printing it in debug mode. As for yo, we are just printing that yo. Yeah. Then what? This is dereferencing. All right, destructuring it. We know that we have seen this destructure happen for point, for rectangles, and all that. We did that. We took the structure name and whatever value it took, and we gave it a variable name which already had this structure type and values assigned to it. And then we sort of gave it to each other and it destructured this far, took it value to these x and y, which is now x0 and y0, assigned it to it. And then we are trying to just print these x0 as y0. And then we are getting something like bar, which is a different structure. And we are doing something like foo is foo, which is something like this. And then we'll pass this foo as fa. All right. Now foo is this value and it takes a value of foo. Now it is taking a value which is fa as a variable, but it is of type foo only. So it will take it obviously. You can see this is foo, this is foo. So pa is also of type foo and we are passing it over here as a foo in bar. And then there is so much foo and foo bar. Oh my god. Damn it. Then we are, taking the real structure and sort of trying to destructure the bar using that. That's what we see. So we say foo is foo, which has x as nested x and y as nested y because it is nested in a bar structure. And then we print this nested x, which is this, and nested y, which is this. Nested x is also a tuple, so we are using a, debug mode because we have not implemented our own display yet, and we shouldn't have to because it's damn confusing. Hmm. So x is 9, we don't care about x. Yeah, that's the earlier whatever response was. Now outside this x0, we are getting from here, which is 1, 2, and then y0, which is 3. This sort of D structure is very familiar to us, so we are good. And this sort of structure, D structure is very familiar to us also, but we didn't use the same foo and foo bar and all that. We used, remember that, we used rectangle and a point. So point had a value of x and y, uh, which was point. And then we took the point structure in a rectangle and gave it something like left width and right height, something like that. And we made a rectangle structure out of it. So we remember something like this, and we have done something like this. So obviously, let bar is equals to bar. So we are learning destructuring over here, I guess. Yeah, that's what we are learning, destructuring the structure. So bar, first of all, we are assigning a variable far, to this variable bar, which is of type bar. And then we are trying to destructure this variable bar by using this original structure bar. And then we are just trying to print the whole damn thing. That's it. So it's not that confusing, but it is definitely, will take a while to get hang of it. I shall move on, which is guards. Now I think we have completed something like a match, and inside that match destructuring. Now we are using guard, and after that binding, and after this match is completed, but not a whole flow of control. If let and let else is and while let is left. So we'll see. So match guard can be added to filter the arm. All right. We know that. Somehow know that. So match guard can be added to filter the arm. So we first of all, allow dead code, or it means don't give us some warnings that we are going to see it definitely, but don't give us. Now we are creating an enum which is called temperature. Inside that we have a Celsius and which is I32 and Fahrenheit which is again I32. Then inside a main to do try different values for temperatures. We definitely will. Inside the main, we have a variable temperature, small t, which is of type temperature, which is enum. Inside that, for Celsius, we are giving it a value of I32, which is 35. And now what we are trying to do is, we are matching the temperature, which is this variable, and we are matching the type of it, temperature Celsius T. If T is greater than 30, then print this, that whatever the temperature is above 30 degrees Celsius. So it's hot outside. If Celsius T is, not, greater than 30, if the if condition part is a guard, so this is called a guard. So we are guarding it somehow. Why? Because, well, in cases where it's less than 30, this condition is not very different from this, but still it will not run because we have a guard over here. So guard stops it, tells you that T is less than 30, so this shouldn't be working right now. You should go to a different, different match. So it goes to a different match and it prints all the temperature which are less than 30. As of Fahrenheit, if temperature is greater than 86, we are printing it. If it is less than 86, we are printing it like this. Like Fahrenheit is equal or below to 86 degree Fahrenheit. Or we also see is equal to or below 30 degrees Celsius. We'll try different values, but first of all, this should be matched. First one, because we don't have a Fahrenheit for now. All right. So 35 degrees Celsius is above. We'll make it 30 and see what happens. It should first of all meet the guard and will come down. So 30 degrees Celsius is equal or below 30 Celsius. That's what we expected. Not this, only this. As for it was Fahrenheit and with a different value like 86. 86 was the value and it was not Celsius but instead Fahrenheit. So oh, Fahrenheit,Heit. It looks like a German name, but is it German or is it some sort of French name? Fahrenheit. Hmm. So what we should get is this second line or the last one, the fourth. But for Fahrenheit, it is the second one. So 85 is equal or below 86 degree Fahrenheit. Then what? Make it not 86 but 186. We'll get this line, which is first one for Fahrenheit, but net is third one. So 186 Fahrenheit is above 86 Fahrenheit. So it's hot outside. Now note before note. Let me check again. Did it drop? Did it not drop? So it did not drop. So all right. Note that the compiler won't take guard conditions into account when checking if all patterns are covered by the match expression. So note that the compiler won't take the guard condition into account when checking if all parameters are covered by the match expression. All right. If it wants to check all the condition are covered by match expression, it won't take this guard into account. We will have to sort of make this wildcard happen. So we should get an error. That's what we are expecting. So we are getting an error which is non-exhaustive pattern, which it is because we are not taking values. Well, it seems this condition and these guards seems like they are making the value, the whole thing, non-exhaustive. But the compiler or the compiler the compiler doesn't take the guard conditions as for checking if all patterns or the match expression is covered. So we have to make this wildcard come up because if compiler doesn't see this, if it will only see that I and then match something with I, then it prints something. If it is I, it prints something. Now it sees something like a wildcard and it says that now it is not non-exhaustive and it does what it should be doing earlier too. We have a I, if I is equal to 0, we say print 0. If it is greater than 0, we print greater than 0. And for others, like let's say if I take something like A, I should get an error, but I could just match it with this. Should never happen. I know what happens. Not found in this code. Oh, A is a character, no? We have to cover it up. Now what? Now what? Yeah. So expected a U8 and found a char. Expected due to this. So compiler gives us an error before even the match gives us that error. And what if in unsigned integer we get -132? which is again a signed integer. I think compiler will show us an error. Compiler shows us an error that we cannot have something like this. If let's say we only had this condition where we were not using this if, now what happens for 0? For normal numbers, I think nothing. We should just get normal numbers greater than 0. As for 0, what will happen? Will it, oh, did I do something? It is still matching with I. I don't know in which case I can invoke this wildcard condition, but I am trying my best. All right, I made it. I gave it a star. I gave it a signed integer. I gave it a value 0, which is in unsigned also, but still we are not mad about anything. We're giving it a sign. I don't know if it is what. Ah, whenever someone gets a call, their network gets dropped. So that's what happened. I hope I am still live. Well, not alive, but live. I think so. I think so. It hasn't been dropped yet. Yeah. So I was trying to, somehow invoke this, wildcard situation, but I couldn't. So might be, runtime or something like that. It was running somewhere like API call and all that. Somehow it got something which is not, uh, let's say U8, and instead of showing compile error at that point of time, it would just, match it with this or should never happen, something like this. I think that's what it is there for. It'll just match with greater than 0 or something like that. Now we just take it come back. Now I think the guard is clear that we need this, to make it inexhaustive, even if the guard is sort of making it inexhaustive in nature. We still should have these wildcard entries for any unpredictable or unreachable cases that we can't figure out right now, but while runtime, someone might, and they might exploit it. So let's move on. Move on from guards to bindings, which is our last case in match, isn't it? Yeah, it is binding is a last case. After that, we'll get if let else, and while let. Good. So binding is good. Looks good. Amazing. Still live. All right. So we have function age, which takes U32, which is now 15. So function age, which returns a U32. All right. Which not takes U32, it returns U32, which is 15 for now. And then there is a main function. So it says, tell me what type of person you are. So first of all, if it is 0 and print, I haven't celebrated my first birthday yet, and could match, 1 to 12 directly, but then what age would the child be? Isn't it? Uh, if match n could match n and use an if guard, but would not contribute to exhaustiveness check. Yeah, if we just used, what is it, binding, all right. So if we just use some sort of if guard, then it would not, considered for exhaustiveness check and not contribute to exhaustiveness check. Although in this case, that would not matter since a catch call. Why is there so much space? Is it by default or something is wrong with this? Yeah, it is by default. So a catch all pattern is present at the bottom, which is n. So it is a catch all. Instead, bind to n for sequence of 1 to equal to 12, and now the age can be reported. All right. So if n is something in between, we are binding it using at the rate. We are binding to the range of 1 to equal to 12. And then if anything, then it says I am child of age, what is it, 12. And then if n is now bound to 13 and to 19, so I am a teen of age n. And nothing is bound, so it returns the result, which is whatever this result is. I am an old person of age 20 years old. 20 years would get old person. Oh my god. What sort of match is this? 19 is sort of teenage and suddenly you got old. So I'm teenage of 15. All right. So we directly invoke this, third one. What if we say something like not 13, but let's say 12. We want to invoke this. I'm a child of age. This was I am teen of age. So I am a child of age. Ah, we got I am a child of age 12. Now instead of 12, we do something like 20. And it must say I'm an old person of age 20. Yeah. So if you are 20 and you are thinking you are very young, no. According to this program, you are old person of age 20. Shit. 20 is also old, 70 is also old. Depends on the perspective. According to this program's perspective, it is quite damn flawed. And if you are suddenly zero and you are still talking like I haven't celebrated my first birthday yet, well, yeah. So we know what this binding is. The main thing we have to follow is this n and at the rate. We are binding it to a range so that we can print that range. Otherwise, how would we able to? We can't just use if and if statement, if statements or the if guards would not be able to, do that, do this exhaustiveness check. But I think this will, because we don't have to enter a wildcard like we had to do with if statements. So you can also use binding to destructure enum variants such as options. So option has two things, I guess. First is R, then second is T. So like result and errors. So R and E, not R and T, but whatever. So option, we are directly taking option, which is enum. We are not describing it. And now option has a value of U32, which is some sort of 42. That's what we are getting returned from this function called some number, right? I don't know why are we doing this like this, because now we are just matching the whole damn function called some number inside inside the function main, and we are seeing something like sum. If n is something like 42, bind with 42, then print the answer is 42. If sum is just n or without any 42 or just any damn number, then not interesting. So it will first of all print the answer is 42, and then it is, since after binding also we can't get the exhaustiveness using n. We had to use this wildcard. So answer is 42. If it is not, let's make it 4. Then we will say not interesting, and number is 4. If it is sort of nothing, then what? Oh shit. It was expecting U32 and it got, well, it didn't got anything. Hmm. Oh, how can we, just hit this wildcard entry? I really want to match this with wildcard, but somehow I can't. So let's make it back to 42. Let's run it. Let's read these comments now. So got some variant. Now match if its value bound to n is equal to 42, like this. Could also use some 42 and print the answer is 42, like this. But that would require changing 42 in two spots. Should you ever wish to change it? But all right. If you ever wish to change it, you have to, make two changes. Now, could you use some number which is n, and if n is equal to 42, then print the answer is 42. But that would not contribute to exhaustiveness checks. And although in this case that would not matter since the next arm is catch all, like this is catch all. So in this case it won't matter. But all right, we should avoid using this if what is this if guard, right? Uh, instead we should use some bindings and all that. So we are using binding with the whole lamb sum over here that we are getting from the result. And in option, let's say we get some errors also, so we can catch all over here. We don't define it as U32, which is like, I don't know what are we getting from here. Just normal to it. We will get compilation error. Expected this but found the integer. All right, so instead of integer, we nothing. Now let's see. Uh-huh. Mismatch type. So expected something like 0, but found an integer in match age. So instead, we should be matching all these, numbers. Expected this, but found integer in match. Hmm. I don't think I'll be ever be able to use this file card. So what? So what? Who cares? Now I think we should move on to whatever this if else or if let is. If let. Well, it is quite not brief, it's very descriptive. So now if let. So for some use cases, when matching enums, which is match is awkward, for example, let optional is equals to make optional of type option I32, all right. So optional is equal to sum 7, and then match optional, which is sum I, then print ln. This is really long string, and we are using a debug mode to print it, and then we are passing the I, which is using debug mode to print it because we have not implemented the print for sum. And then for wildcard, we are doing nothing. Now we say this is a really long string and 7. So this is a really long string and here we get this value from 7. So for some use cases when matching enums or match is awkward, for example this, if let is cleaner. For this, like matching just it's embarrassing over here. That's what he's telling. So we have another method which is if let, which is a cleaner for this use case, and addition allows various failure option to be specified. So for main, all have types option I32. Now number is option I32, letter is option I32, which is none. Emoticon, which is emoji. What is emoticon? I think it is emotes or emojis. Option I32, and it is also none. So if let constructs the read, which is if, and then let destructures the number into some I and evaluates the block like this. So if let, then some I is equals to number, which is print ln, then match the I is getting printed over here inside a number. Damn, I don't understand this for now. But there is if let, and then there is some I. Inside that we are using a function, sort of function or a block, which is called number. Number is this, number was this. It says print unmatched I. So I think it will get 7 from here. So it is destructuring this number, which is of type option I32, which has a value of sum in 7. So it gets the 7 value from here, and we are just printing that 7. So first thing we should see is mashed and then 7. Mashed and 7. That's exactly what we got. And then if you need to specify a failure or use an else, we can do something like if let scope is letter and we are matching I, which is 7. Else. Destructure failed and change to the failure cases. So if destructure failed somehow, uh, so we will print didn't match a number. Let's go with a letter. But that's not what's happening right now. Didn't match a number. Let's go with a letter. Why the hell? Because there is no letter. Letter is something like none. All right. So letter is none. So it says this didn't match some sort of number I, because sum has no I over here. So it said didn't match a number. Let's go with a letter. So if statement for this let is not working, we are making a else statement for that. So it's just like we are looping over, we are just using nested if, and inside that we are nesting the whole let and all that, destructuring. That's what it looks like. So if let is just destructuring inside a if statement. So we are destructuring all the enums and everything. For here we are using option I32, but inside a if statement. So if and else looks the same. If let some I is not a letter which is of type none. If it is there, I should be printed. If it is not, let's change it to number. Then I think it will just print the if statement, which is mashed, and then we'll say 7. It will shout 7. See, it mashed 7. Now let's move on. I think we understood this. Let's move on to this. So let I like letter is false. All right. Provide an altered failing condition too. So I like letters is false, and if let some I, which is emoticon, which is none. So this is getting none. So this won't be printing. Then we are using a else if. So if else if I like letters, which is false, so this will also not get printed. So what will get printed? I don't like letters. Let's go with emoticons. If this was true, then I guess this would have been printed. Uh, let's make it true. TRUE. All right. I think this should match. Didn't match a number. Let's go with a letter. Yeah, let's go. Everything is working. We have a great understanding of this, what's happening right now. It's just if statement, else if statement. Just what's happening in this if statement in itself is we are destructuring something which was complex, and we are using match for that. So instead of using match, we are now using if else. And that's what we have done somewhere. I remember while making my first calculator, I didn't know the match function in C. or it was not match. It was something like doing match, but the syntax was different, isn't it? So I didn't know there was a match function for C. So I used if else statements on operators, and if operator was plus, we added A and B. If operator was minus, we subtracted A and B. We were using if, else if, else if, and at the end, if we didn't get a sort of number, we were handling those errors. So we were like, we didn't get this number or this number, whatever that was. So we now know what we are doing over here, which is if let's. It's the same as making calculator using if else, but in Rust. So yeah. Now this syntax looks funny to us because it somehow is, but I like this format. I'm liking this. We are destructuring emoticons to let some I, which is destructuring it, and then print some I if it is there in emoticons. So if let's say this is not also emoticon, we want to print the first statement which is matched I, we'll just give it a number. Was it number or small number? Right, it is small number, UNBER, and it will just print, hey, I am 7 or matched 7, something like that. Yeah, now all three statements are matched 7. So I think we understood this the first bit, which was earlier just trying to tell us for this case, which was some option 7. But now using that first case, we are now making it much more interesting using if let and if let else if let else and all that. So this was interesting. Now, in the same way, if let can be used to match any enum values. Yeah, we have, because in if statement, we are using let and destructuring any damn thing that is there. We can destructure structures, we can destructure enums, we can destructure any sort of arrays, tuples, anything. We can do anything over here. We can destructure result, which is enum, I guess, earlier, a predefined enums. All right. So our example, which was enum, which has now foo, is our enum. It has type bar, baz, and kuz. So kuz is taken u32. Let's leave it alone. And inside this main function, we are creating example variables. So like we have a foo bar, which is we are assigning to A. We have foo bars, we are assigning to B, and then C, we have quiz of 100, we are assigning to C. Now what? Now we are using if let. If let is now checking, first of all, destructuring this foo bar of A over here, and says if A is a foo bar, then do this, and that's it, because this is only if statement. And variable B does not match foo bar, so this will be printing nothing. So yeah, because this is foo baz instead of bar, so yes, this won't be printing anything. But if we use some else statement telling it that this is not foo bar, this is foo baz, then it would match it. What should we print? Oh, that we should print something like just print it. All right, we are not doing anything. We are not making assumptions. We are not checking anything. We are just printing that B is foo baz, not a foo bar. All right. These damn spelling mistakes. Foo bar, foo baz. Oh, oh. All right. So now, since it was printing nothing, but now we have used else statement, so it will print something, which is B is foo baz, not a foo bar. B is small, so we'll make it small. But we are getting the point. All right. Now variable C, well, I would have gotten some really nasty errors, and I wouldn't have an idea of why. But now we have, and we shouldn't get any errors. But it timed out, so playground can time out sometimes. That's what it does. So now we get A is a foo bar, B is not a foo baz, B is a foo baz, not a foo bar, and if we make it foo baz, we should be good to go with our own foo baz. Yeah, same foo baz, foo baz. So this statement should be printed like B is foo, not foo bar. we made it foo baz. So B is foo baz. Right. So now we know we can do this, and variable C, which is this 100 inside foo cooks. Ah. So variable C matches foo cooks, which has a value. So we are destructuring that value from C into that again foo cooks and value, and we are printing that value. So if C is that value and whatever it is, and that's it. It is iflet like normal. This iflet, all right, and this is simpler than the earlier one. Now what we are doing is we are binding the value directly to the 100 inside this. So we directly say C is 100. But if it is not, we get this. We obviously get this. We will, in all cases of C, we will get this. But just for 100, we will get C is 100. So let's change it to 0, 0. I don't know why two zeros, but let's go with it. So this shouldn't be printing. Yeah, it is not printing, and C is a just 0, not 0, 0. Now let's revert back these codes because they were interesting somehow and they had a personality of their own. Let it print. Let it go. Yeah, we don't get anything for B because B is not a foo bar. Well, is not a foo bar, it is foo baz. So this does not do anything. And we had added those these else statements, but now we don't have those else statements because we reverted it back to the original form. C is the same, but C's value is 100 also. We can make it change to 0, 1, 2, anything. We've seen what happens. We don't get this this binding thing because it is sort of bound to 100. But if we do not get a foo books of value 100, we don't get to print it. So I want to check again something. What if we remove this? Will we be able to print this? But why are we assigning it over here? So now in all cases, like even if it's not 100, let's say it's 109, still it will print this C is 100. So that's what happens, I guess. No, no, that's not what happens. So why did we have to, bind the value to this 100? I don't understand it. So binding also works with iflet, and not binding also works with iflet. So why are we still binding it? So variable C matches foo cooks, which has a value similar to sum in previous example. So why are we binding, value VALUE at the rate? I guess for just our own understanding, and if we wanted to print the value, like right over here, we could do that by saying this is value. But if it is just 100, we wouldn't be able to, for now, we have to make it first of all 100, then only it should work. 0, 0. Yeah. So now we can, using value, we can print value. If we are not printing value, then I don't think that binding value with 100 is of any use case as such. All right. Now we have another benefit from iflet. Let's check it out. Iflet is done, then what? Then there is let else and while let. So let's complete this. All right. So another benefit is that iflet allows us to match a non-parameterized enum variance. Now this is true even in cases where enums doesn't implement the derived part partial equality. In this case, if foo bar is equal to a, would fail to compile because instance of enum cannot be equal. However, iflet will continue to work. Would you like a challenge? Fix the following example to use iflet. So what is this? We have enum foo bar. Inside A, we are assigning it a foo with a value bar. Now, variable A matches foo bar. Yeah. Earlier, how did it match? It matched it like this, but now we are using double equals to. Earlier it was let, now it is just if. So if foo bar is equals to a, this causes a compile time error. Use if let instead. We know that, and we shouldn't be just using the equality or partial equality variable. We should be destructuring it and then using that foo bar. That's what we did over here. We are using equal to because we are destructuring a, which already has a value of foo bar. Again, the same thing over here. A already has a value of foo bar, so we can destructure that a over foo bar, and then if let will let us print a is foo bar. So let's first of all run this. Let's see what sort of compiler we get. So it says foo, and inside over here it says minus foo. So it's something like binary operation, and equal to cannot be applied to foo. Implementation of partial equal to might be missing for foo, and all that must implement partial. So we have to implement IMPL using partial equality. We can do that. We can derive, consider annotating foo with derive partial equality or derive partial equality. Can we do that? Let's try doing it first. Let's try doing it first. Let's try doing it because that's what compiler is telling us. Uh, so take the home, get a new line. What will this do? We have never tried it, but let's see. Ah, damn it. We fixed it. Shit. All right. Let's make it foo bars instead of bar. So will it be able to be partial equality or something like that? Foo bars. We have changed it. Now now let's do it. Uh, or is it? Yeah. We had something like no variant associated item bars found in foo. Ah, shit. Because there is no foo bar. So this was error. Now what? Now what? Now what? Now what? Hey, what happened? No variant associated with bar named is found in V. So it's telling me, so I can't do this. I can just change bar or something like that. Let's undo this. All right. I think we can't do this because it's telling me directly to change it to something that is there in the enum. How about we copy pasted the earlier enum? Now it is everything. A is a foo bar. Let's make it bias. No output. Yeah, now it works. So derive partial equality worked somehow. We did not use if let statement like this, and we did not even destructure this A. So this also somehow worked because of this flag, which is derive partial equality, which made it work. So now let's use without derive equality because we have made some changes to it, like if let and yeah, so we still got a, so this program wanted us to do this, but instead we read a compiler error and we got this line, which is a code in itself. It's like a quick fix. All right, if we don't know what's happening right now and it's telling us there is a partial equality error, we can just quick fix the whole damn enum instead of going to all these cases and matching where we are doing the mistake. All right, so let's move on. If let is done, now we'll see let else, which is a small, and it says stable since Rust 1.65. So what is the version of Rust? RUST, Rust C, I guess. Version, version 1.92, 2025, 12.8. All right. So Rust C is that. So I think the Rust language is also 1.92. Let's get this done with. We have only 11, now 10 minutes. All right. Stable since Rust 1.65. You can target specific additions by compiling this like Rust C and addition 2021 main.rs. Can we do that? Because we are getting it with time, but we have to install it also. So let's try it. Let's try it. Let's try it. Instead of main.rs, since I don't have that, let's go to some sort of you know practical learn inside Rust, inside not this 0 6, because on day 7 we did not do anything. Let's go to day 5 because we have single sort of cd to day 5 with single Rust files like this. We can just say for 8.rs. Let's compile 1.rs, not 8.rs. So error, expected this, found that, not 1.rs. Let's do it for 8.rs. So it did compile, whereas we had a version of 2025, but we are now doing it with addition of 2021. How is it doing it? I have no idea. But let's run 8.rs and it runs. So, well, it looks wonderful. It is wonderful. So let's move on with if I try doing it again, you know, just erase this. Will I get some sort of help? Not 2.rs. I want to see some addition help. Addition, nah. I don't think there's a addition help right now. And doing it normally, well, it also gives me the same addition. So with let else, a refutable pattern can match and bind variable in surrounding scope, like normal let, or else diverge, like break, return, or panic. So when the pattern doesn't match, like something like this, the scope of name binding is main thing that makes the difference different from match or if let else expressions. So if you could previously approximate these patterns with an unfortunate bit of repetition and an outer let. So let's see what the code says. Use standard stir from stir. That's what we are using. So function is get count item, which is s, which is of reference stir. We are getting this return from this function is as type of u64 and a stir. Then we have a let mutable it, which is s dot split, and it is splitting using space. So now let some count stir and some item is equals to it.next and it.next, else we have panic can't segment count item pair, which is s, and let okay count is equals to u64 from stir count stir, else panic can't parse integer. All right, we are doing all that, and then we are returning count and item. So count is count, and item is this. So in main, we are asserting that get count from 3 chairs is 3 and then chairs, because we are separating it using this. So yeah, it somehow works. I don't understand what's happening. So we will just have to spend some time with it. And if it is not covered today, we'll cover it yesterday. Oh, sorry. Why yesterday? Yesterday is a day before. We'll cover it tomorrow. All right. Now the scope of name binding is the main thing that makes this difference, like match or if let else expression. So you could previously approximate these patterns with unfortunate bit of repetition and an outer let. So let count star and item is equals to match, and then we are sending it next and it next. Inside that we are using some count. It's very counterintuitive if you say. So for some count string and some item, we are directly, getting the return for counter string and items. But if it is anything else, we can just say can't segment this item pair and it panics. And we are doing or implementing the same damn thing with a bit more clarity because of this match statement. Uh, and it has two things to match with. So some count star and this item. Then there's let count is equals to if let okay count. And then inside that we are saying U64 from string, which is count string. So we have to count, else panic, can't pass integer, which is count string. Uh, if we make this happen, nothing will go wrong or can go wrong because there's no function main or there is. Let's see. Yeah, it's using same thing over here. Yeah, nothing has changed for this. Get count item. And the implementation just changed. Instead of using, you know, let and then destructuring it and then using else and then panicked. So that sort of pattern changed. And why are we not using if? Also, it's not if let, it's let else. So if there is something like, for example, you want to destructure it, we just use let. That's what we already do, and we destructure it, and then we say else. Right? I can't just edit it, but I'd like to. And then else, if this showed some sort of error, so then we have an else which will sort of catch that error and will say panic, can't segment count pair item. Now that will be called as very, what do we call it? Very generous sort of error arguments is there. It is handling it very gracefully. Over here also we are counting or checking if it's okay count. Okay count from where? Okay count from count. Where is this count we are getting from? Okay, so count is like defined as U64 from string count star. So this is now count. So if we are getting some counting from this, then we say okay count, and that's what we send directly. Or else we say can't pass integer and count star. So that's what the error is. Then we say we are now returning because every function has to return. We can't return it directly from here because we are using semicolons and we can't even edit those semicolons to check whether we can remove them and directly send or return it from here. But after, if we just return it from here, then this let won't work. So that's why we are using the return function at the end, which is returning count and item. And inside main, we are just asserting the equality of get count item. This function inside that we are sending three chairs, and we should get a result which says three and chairs. Uh, we can't make a print statement out of it so that we can make it more dramatic, but that's all right. Now with the same implementation, we are using the same mute as and splitting it. So, and we are using the same count star item and it.next. We are iterating over this it and it.next. We are getting it. Next is sort of a method that I have seen somewhere else also. So yeah, for arguments like command line arguments. So let's say if I say something like for 8, I want to pass some arguments like I, J, K. So how to iterate over these arguments? So we use next over there also. So that's why I was guessing we have seen this next somewhere. It goes to next argument or next whatever this is. So it goes to the next split, and that's how it's counted. So if there is a count and item, then we have a count string and item, as we have a panic. And if the count is okay, so if let is okay from over here, then count becomes this count star, which is this, and we then return a value of count. Else we can't just pass the integer, so we'll get count star is can't pass the integer, and we are returning the count item as usual. So what is RFC? You will see that new tab. Now let's move on. Now this is our last example, which is while let. So similar to if let, while let can make awkward match sequence more tolerable, consider following the sequence that increments I. So make optional for type, option I32. So let mute, which is optional, sum 0. So this is now 0 and of type option I32. So optional variable became sort of a type of I32 and it has a value of sum 0. Now repeatedly try this test. All right, let's first try this test. What's happening? So for loop, we are matching optional. Yeah, match optional. And sum I is like if I is greater than 9, then print greater than 9 and quit. So optional is equals to none. Else what? Else print I is whatever the I is and try again. And optional is sum I plus 1. Then requires 3 indentation, because we are inside loop, inside matching, inside matching the sum, and inside that we have used if else. Now this looks awkward instead of just match. What are we getting? I is 0, so try again. Then we increment it by 1. Then we get 1. Then we get 2, 3, 4, 5, 6, 7, 8, 9. And as soon as we get I is 9, try again. And as soon as it increments to 10, we say greater than 9, it quits. It quits how? It quits like this. Option becomes none. So sort of next time it won't have any value and it then breaks because match won't, match won't be able to match this optional with some of the value I 0 or anything because now it is none. So it breaks over here. And if we wanted to sort of name this loop as outer loop or something like that, we can do that using we can edit it using this single quote, or what is this, apostrophe. Yeah, it's the same thing. If we quotate it or quotation it, we get a single quote. If we don't, it's just apostrophe. So we use apostrophe, let's say outer, and then break the outer. Good, great. Now using the while let makes this sequence much nicer. It's telling me using this loop was damn awkward. So yeah, this was awkward. So it's telling me this is not the implementation that we should follow. Thank God, it is giving us something else to work with. Now this should also return the same damn thing, but here it looks sort of nice. So for while let, we have a sum I which is optional, and we are matching that optional if I is greater than 9. So then we say greater than 9 and we say optional is none, and it already quits it because option is none. We don't need to explicitly say something like match all if it is none, or something like else. We can't do anything that break the loop. We are not doing anything like that. Else we are doing the same thing. We are printing the I and say try again, and then we are incrementing that I. So if I is 0, we print this I and then increment it by 1. It makes it 1. So what it says is makes optional of type, option I32. That's what we did earlier. Now this reads the while let destructure original into some I. So we are destructuring this optional into some I and evaluates the block which is inside this block, which is these. Else break. So there is no else break that I can see. It is sort of fundamental or already obviously there. Hannah, it's not even hidden somewhere. So less rightward drift. Yeah, there's only two indentation and sort of less sort of nesting, and nesting is always prevented in all sort of languages. To check these conditions, we have to check if it is inside loop, it is inside match, it is inside sum, it is inside if. So there is some sort of 4 sort of indentation over here, just while, and inside that if. We are checking if and we are passing it some value, or we are passing it none. So less rightward drift and doesn't require explicitly handling the failing cases. Yeah, we don't even match the wildcard, so it's great, and we are not even using match, so that's more great. So now if let had additional optional else and else if clauses, while let does not have these. So all right, we can go with that because there is inside while let we can use if else statement like normally. So I don't care because we can always do this. But if some I has not a value of I, like it's none, it suddenly becomes none, then we directly go out of this while loop. And if we wanted something like else print this, we won't be getting that facility. So yeah, I get your point, but it's still workable instead of doing this sort of damn nesting. But all right, so I think we've finished our eighth module. This is our ninth module, which is function. uh, I think tomorrow we'll start by first of all revising not the whole eighth module, but just these let, else, and while let. If I wanted to do it, I will do it. And now tomorrow is our ninth module, which is function, which is well, it seems like it's small, but I don't think it is, because function is, yeah, it is definitely not small. So we have to take some time for this also. All right. Let's see this RFC book. So this is RFC book. It has summary. It has motivation. So this is Rust RFC book. All right. This has examples. It has implementation. Good. It has let else implementation, a practical refactor, and it has not too much for let else only. Let else has summary, motivation, and all that. So first of all, just complete what we have on our hand, and then we might, go over these someday. For now, bye bye. And